Hey, what's going on, guys? Kenzie here. In this video we're going to be testing Tiny Basic by Tom Pittman. So here is a little story behind it. I found this fantastic website by Hans Oden introducing the Q1 software, and among other programs, here we have this probably, I believe, the smallest available basic for 6502 processors, so it's around 2K of memory. And first, I've been using this precompiled binaries, but they didn't quite work for me because I'm running this on Arduino that runs Q1 emulator that I'm currently building, so it's quite a complicated setup. But fortunately, thankfully to this CC65 assembler resources, I managed to recompile them to fit my needs, basically. So I'm gonna be covering this a little bit later by this video. All right, so first, let's go for a demonstration and then through what I've changed so far. And then finally, eventually, by the end of this video, we're going to be talking a little bit about the comparison of this Tiny Basic versus the so-called KB9 or Microsoft Basic that was available at the time, but was much more expensive. So sort of a born of open source software. How this happened back in the day is going to be covered as well. So let's go to the Tiny Basic manual as HTML, and I just want to drop back to index. So here already we can nicely see all the statements available here, and I want to start. I want to start with this because, probably the most significant thing to consider. So the instruction set for this Tiny Basic is extremely small, and it's really less as opposed to, say, Microsoft Basic, and also it's an integer basic, which on one hand makes it running faster. On the other hand, you don't have the opportunity, the option to work with floating point numbers. But who cares about the floating point numbers? We're not going to be writing the 3D graphics here on 6502 processor. Well, some guys did on C64, but here it's not the case, really. And again, if you want to go for 3D graphics, you really should consider the integer approach, which would make it really faster. Right, but it's not the point. So we have the print to print the strings, input to take the user input as integers, let to either assign or reassign the variable it's essential. Then go to self-explanatory, GOSUB, a subroutine call, return, it's just return from the subroutine, if self-explanatory, and should be placed by the end of every program, for otherwise it's not going to be working. RAM stands for remove, it's just to define the commentaries. Clear to define to clear the user space, the memory where the program is stored into the within the RAM. Run to run the program, and list to list the program. So it's extremely minimalist set. However, it's as powerful. It's literally as powerful as the Microsoft Basic in terms of you can do. I can't imagine something that you can do in Microsoft Basic, but you can't do here, because yes, we don't have the for loops, but we do have this GOTO, and actually this works even faster because it's just faster to shift the instruction pointer as opposed to processing the entire line of this for loop and handling the specific syntax, building those abstract syntax trees and things like that. The way it's done in the modern era, really. So yeah, without further ado, let's jump in. And yeah, and also there is a fantastic user function which we'll cover here in this video as well. And yeah, and the random one is also one I love. So the origin, originally there were two origins possibly available for Tiny Basic, either starting at 200 hexadecimal or 2000 hexadecimal. But in both setups, the program code, I mean, like those ASCII characters representing the source code of the program were stored after the program. So I've changed that. We'll cover that later on while inspecting the sources. So here now I have what I did. I literally turned this Tiny Basic into a sort of a ROM. So I read the execution routines from the ROM, from the flash memory in my Arduino, and they are mapped to the address of 200, so press space. And yeah, also I've added this function to a feature to echo the character whatever I'm typing into the terminal emulator. This wasn't originally like that, but without this feature, you just can't see the code that you input as the basic program. So I think that's a reasonable trade-off here. And now to run the program, Shift G, and we are in the basic, guys. Can you believe this? Yeah, I've also changed the appearance of the prompt a little bit. So this was initially was like the colon. I've changed this to this greater sign. But anyway, so let's start with the classics, so we can print the strings. And what is even more fantastic about this is that unlikely, for instance, unlikely the integer basic by Steve Wozniak that was eventually shipped with Apple I computer, it does support the lowercase letters for printing strings, which is really cool, I believe. So, for instance, on Apple I Basic, you can only print strings only containing the high level, like uppercase letters. Okay, so we can also print the numbers, and we can also print expressions. What I really like is that we have this simple integer arithmetic. So just to give you an idea, that for instance, the 6502 processor doesn't really have an instruction to multiply two numbers. However, this basic does allow doing this. Well, it's a software multiplication. It's slow, but it kind of works. And even the division, which is definitely not included into the 6502 instruction set. So let's say we want to print like 32 divided by, I don't know, by 4, and we got 8. So it works like a charm. We can use more complicated instructions as well. So for instance, the parenthesis can be used here. So 2 plus 3 and multiplied by 10, for instance. Here we go. 5 multiplied by 10 equals to 50. So far, so good. Now let's try to input some lines. So far this was executed on the fly, so it didn't really take the memory. Well, maybe it took some memory to store definitely took the memory to store the buffer, the user input, but there is no program memory. So if you just try to run, we see like an error. And by the way, if you're wondering about the errors, so this numbers we can always be referenced here at error message summary. So for instance, 13 run with no program in memory, which is exactly the case. So we can run in this case. So let's go. So let's say, for instance, 10, and here we want to say print hello, and 21 to print world like this. Now we already have a program, so which means that we can list this program, which is fantastic. And another interesting feature in regards to this basic. So if I run now, it kind of runs, but it still gives an error. So 75 means print not followed by the end. Well, actually, not only print, but whatever we have here, whatever program we write, it should end with the statement end. So we just say 30, and here I put the end, and we can list this again. Then yeah, now it looks like a real program. And yeah, if I just say type list in the lowercase letters, it also gives an error. So 184 missing statement type keywords. It just doesn't recognize that. So in order to make it work, you need to make sure that you're typing the uppercase. So list like this and run like this, and now runs perfectly well. So no errors, and it prints like executes this kind of statements one by one. Okay, so now let's try to do something more interesting. So, well, another option. So, for instance, if I want to, if I say like this, so just one without printing anything, and then trying to list again, you see like I've just removed the line number 20. And for instance, if I say 10 and then replace it with something else like this, and list again, then you see like it just gets replaced. Well, whatever I print here, it gets replaced. So yeah, and also if I just clear and try to list again, now we're just clearing the program memory, so there is nothing else any longer. Okay, now let's say 10 let a equals to 0, then 20 let I'm using let here again because I want to reassign the variable. I still need to use this let, and yeah, it only loads this uppercase one letter variables, and they are pre-stored in the 0 page of the 6502. So that's another interesting option. So you can, if you just escape from the program, you can just inspect the memory using the hex monitor and see what are the values for the current variables you have. So let a equals to a plus, and by the way, it allows to put the spaces in between. So a plus 1. All right, then 30. I want to print a, for instance, and now I say if a is less than, let's say, 30, then go to, and I want to go to here, go to 20. Okay, and then finally end, and let's list our program. I just enjoy doing so. Okay, so here is the program, and now let's run it to see what happens. And now it just executes the loop. So no matter that we don't have for loop here or while loop, but we still can loop using the GOTO, which is absolutely fascinating. For me personally, I enjoy this so much, guys. All right, now for instance, we go back to list, and instead of printing a, we can just print a string and then the values. So for instance, 30, I can say print, and I can say number is, and then comma, and then a, and then list. So we just changed this, so now we can run it again, and here we go. Well, it's quite laggy, but you just bear in mind that this is Arduino. There's not the real 6502, so it's definitely slower because it's like not even the direct execution, but it runs the 6502 emulator first, and then it runs the CIM-ROM, and then it runs this kind of basic interpreter. So it's quite slow, but still quite fantastic, I believe. And what else to show? So probably I also want to demonstrate how this GOSUB works, and that would be pretty much all about it in regards to the statements, and then we'll have a look at this predefined functions. So for instance, well, let's just clear the memory. So list, we don't have anything else. All right, so now let's say I want to do the following. So here I want to say GOSUB and 30. So whatever subroutine available at line 30 is, we're going to be going there as to execute the subroutine. And here I just want to end the program. So after we just end the program, so here let's say print this is printed from subroutine, and hit enter, and then 40, it's just return from the subroutine. And let's list the program. Here we go, and run. So, and it prints that yes, this is printed from subroutine, and then returns. So so it's here, then it goes here, prints the line, then it says the return, drops back here, and here it says, okay, this is the end of all the program. We're done. That's pretty much all about it. All right, so a few more functions. So one of my favorite, this random. And by the way, yeah, we can actually try and okay, now let's quickly enter the program that we had, or even better, let's just have a look at the example programs here. So for instance, this one is pretty small, so let's consider this one. So display 64 random numbers less than 100 on 8 lines. Okay, so let's try to input this program. But by the way, I didn't yet try that, so it's gonna be interesting. Hopefully it works. So starting from 20, and let I equals to 0. And this is what I've been doing when I was a kid. But as far as I didn't have an option to save my work to the cassette tape, I need to retime the game every time I wanted to play it. So yeah, I've been telling about this countless number of times, but still. All right, so print, and now rnd, which is the random function. in 100, so in the range from 0 to 100, or from 1 to 100, I'm not sure, I need to check the documentation. 40, let I, okay, if something goes wrong, it doesn't have the added in feature, so you need just to retype from scratch. So 40, let I equals to I plus 1, so increment I by 1, and then 50 if I divided by 8 multiplied by 8 is equal to I, then print. Whoa, what an interesting syntax. What actually wants to print? Then print I apparently. Is this a typo? I don't know, let's have a look. So 60 if I is less than 64, then go to 30 and 70, and so let's list the program. So let I is equal to 0, print random in the range of 1 to 100, let increment the I if, then print. Well, this line is a bit strange to me. I didn't yet test this. I'm really wondering, is this really going to be working? Let's then go to 30, and yeah, let's try to see if this kind of works. Oh, probably, yeah, probably this is what it means by 8 on lines. Well, maybe here is something wrong with my PuTTY terminal emulator. So maybe this should be printed as one line. So I'm not sure yet if that is the case. So probably if something goes wrong with it with this terminal, then terminal emulator, in that case might be an issue. So I'm not sure how the output should look like. But anyway, we definitely see that the numbers are grouped, and also obviously the numbers are random, which is fantastic. All right, so now the user function. I didn't yet go deeply into that, but what I've learned so far is that the user function. So we just input the address in decimal, which is important. So it doesn't take in hexadecimal; it takes in decimal of where to put the program counter of the 6502 to execute whatever bytes are available there. So, for instance, one of the options for this might be the following. So let's say, so yeah, and in order to actually make it work, I can't do just like user 0. So this, well, in theory, this should call whatever routine available at the 0 page address 0, but it gives an error because it's just the wrong syntax. So we need to assign this to the variable, and then it just works fantastically well. I'm not sure why exactly the variable assignment is needed to be. We'll also probably need to learn this a bit more. But anyway, so here, what happens now, it would now try to execute the routine at the 0 page address 0, and there is, I believe there is a 0, and 0 means break, so it should just return to the key monitor. And we are now currently in the key monitor, so 0, 0, 0, 0. Yeah, so it just executed here, and this is ready to be as the break statement. And yeah, we're just got back to the monitor. And for instance, here, if I go to 0, 0, 0, 0, and here I say like A9, yes, and then let's put the value of 34 to a register, and then break. Then, so what happens if I just execute this 0, 0, 0, 0? So if I run this, it should put the value of 34 into the A register. So let's check this out at the address of F3. Here we go, 34. Now let's 0 this value. So 0, 0, F3. So yeah, so like it's no longer there. And now we go back to basic in order to, so here we can use what is known as the warm start. Since we have all the variables being initialized, I'm using to 2003 instead of 2000. Shift G, or maybe, okay, not sure. Hold on a sec. just wondering. Okay, guys, I'm not sure why it doesn't work, so let me just reset, and we'll go a little bit different way. So I would say now A9 and 34, and then I go to here. Oh, I didn't, oh my god, I didn't press enter, press space, that's the reason. But anyway, yeah, we're back to the basic interpreter. And now if we say let a equals to user function available at address 0 and hit enter, we go back to the key monitor, and 00F3 now should contain the value 34, which is exactly the result of running this program. So how are we going to use this? So for instance, if we have some useful user programs somewhere in the RAM or in the ROM as well, for instance, like to copy, to dump the memory from RAM to EEPROM, for instance, to save our work, that might make sense. In that case, we can easily call these functions directly from BASIC, not from the key monitor, but directly from BASIC. So, and this reminds me, and please pay attention, guys. This is very important, because this reminds me. Not even reminds me. Yeah, well, actually, this reminds me of the system scripting language on the modern operating system. So, for instance, like the shell script on Linux. So the idea is that you can use a sort of an interpreted language in order to manipulate the system-related data, and that's really awesome, because yeah, you can just write a basic program that does something useful directly with the environment you're working within. And as soon as I implement the feature to the option to write to the EEPROM on my Arduino-based K1 emulator, that might be the case to play around with. And if that's going to be fun, I will probably make a video on that as well. Okay, so I guess we've covered everything I wanted to, and now let's have a look. Finally, let's have a look at the source code. So we'll start by, so here I have this, so here is the binary that I've assembled, and here is the source code. So I've slightly changed this. So initially it had the routine at 100 hexadecimal for break that was set in the carry flag based on whether the 1740 address was going to complete the output to the terminal or not. But this is the hardware specific for the real K1, and as far as this is the emulator, we don't really need to care about that. So all I do here, I just clear the carry flag just to make the interpreter working properly. For otherwise, if it's set to true, it just doesn't load to make the subroutine calls, for instance, and yeah, some other features might not always be working as expected. So another two features, as the documentation of Tiny Basic states, it's intended to be platform independent. So we just need to set up the pointers pointing to the routine, to the ROM routine, so whatever machine you're currently working on, that do allow you to get the character from the keyboard or whatever input and output the character to either serial monitor or video monitor or whatever. And these are used, yeah. So out v just prints here, and yeah, the get character is also not sure. Env takes the character, and here we have just the jumps to the cold and warm start. So the difference is very simple. The cold start initializes the variables that are needed for interpreter to work, and the warm start might be used when you just want to drop back from the key monitor, for instance, back to the interpreter, which I failed to do because I just forgot to hit that space button. But anyway, it's not the major thing. The major thing is the following. So the first and most significant thing I've changed is the free RAM offset. And by the way, I want to make it like this. So initially it was I don't remember, it was 2900s initially. That's just right after the program of the Tiny Basic itself ends. So currently it's at 200 hexadecimal, and that's where usually the common program for K1 is going to be located and running at, the starting address for program. So well, probably one more interesting thing to show you, to demonstrate, is the following. So let's say, for instance, here, let's reset things first. Right, and I go to 0200, and here you see like we don't have anything there, right? But if I go to 200 hexadecimal and run, and now I say, for instance, 10 and A, it's not valid, but you will now understand my idea. 30 C, and then just to drop back to the monitor, A equals to user 0, and we are back to the monitor. Now 0200, and you see this 0A, which stands for this 10, and then just the byte just to separate the number from the data. And then you see the 61s. These are the ASCII codes for A characters, and then we have then we have probably 0D is 13 in decimal, probably carriage return. 14. Not sure what that stands for. Yeah, 14, is this 20? Yeah, probably 14 is the hexadecimal value of 20. I believe that should be the case. And then we have again like the separating bit, and then 62s are the ASCII character B codes, and then we have the ASCII character C codes here. So it's like the basic program can be written into the RAM of the actual RAM of the Arduino, and it can go up to 03FF, up to here. The rest are just not handled by the interpreter, so yeah, they are just not available there. All right, so this is how this is another interesting option. So by changing this this offset, I've separated the execution, or the part that executes the actual basic program, from the user program space, and that allowed me to run the tiny basic completely as a ROM, because like it's a read-only memory, so we don't need to write anything to where the program itself doesn't overwrite itself, and all the variables it serves it uses are either in the 0 page or in this user program store. And by the way, there is a nice memory layout, a little memory map. So here we have the address. Well, they might not be 100% perfect for 6502 system, because most likely they are intended for 680, 6800 systems. But anyway, the idea, you got the ideas. You have this 0 pages used for the variables mostly. All right. So this was the first and the most significant part. So then I've removed the routine, the break routine, from the 100 hexadecimal, because we don't need this, and I just clear the character flag to make it working properly. But the most significant and the most interesting thing, an extremely interesting part here, is that the reason why I was doing this, I wanted to purify the output. So originally the problem here was that if you go to basic, then instead of this nicely printed greater sign, it was just so instead of this nicely printed sign showing that this is the prompt basically, it had some non-printable character with just a break on a screen over the green, like a cursor, but with some dots in it. It was either FF or I don't know, yeah, probably the value of FF in ASCII, or I'm not sure, but it doesn't matter really. Then the ugly colon, and after again like some non-printable character. But what is even worth, the problem even worth here was that when I was trying to list the program, it only printed the first line number and then some unprintable character, and then it dropped. So it didn't print any further. And I was breaking my head. I was trying to understand what exactly is that happening basically, and I couldn't. And then I thought, well, okay, so maybe I had the run command working properly. So I thought, well, maybe I just don't have list working, but I can live with that at some point. But at very least, I will try to make it look a bit better, a bit smoothly. So here is the hack, and I'm really proud to present this here. Well, currently works the following way. So if we have the character above, this is the hexadecimal value of 127 in decimal. which ends up with a printable ASCII characters. So everything that goes upward than this value are non-printable ASCII characters, and in that case I'm not jumping to the output character subroutine, but instead I'm jumping here to this newly created subroutine, which simply returns and doesn't do anything, it just doesn't print anything, right? And this actually resolved the issue with the list that now works properly, because before this the list didn't work, and I just wanted to prettify the program, and eventually I ended up with fixing the entire list command to work properly. So that was really fun. And what else to say? Just one last thing before I go. Yeah, so eventually I was trying to figure out which non-printable characters exactly was printed, and instead of outputting the ASCII character here, I was printed. There is a nice kim-rom function to print whatever we have in the A register in the format of 2 hexadecimal digits. So I was figuring out the ASCII codes for those characters, and then I was making the custom. Compares here, and whatever characters didn't match, I just dropped that from printing and then returned. But then I realized that that sometimes they were some new characters were appearing during the program the interpreter workflow. So I decided that probably just disavow whatever non-printable characters that go above the threshold of 127 in hexadecimal, and that kind of made the trick. And I was I was really confused by that, but I was really happy to have this extremely simple solution to fix literally everything just straight away without much effort. So yeah, this is in regards to the alterings that I made to this program, and this is compiled with the CC65 C compiler that provides the binary executable, but actually it has the custom makefile that just uses the assembler. It has the assembler by the way as well, so yeah, it just uses this assembler to assemble the code, and we're done. So yeah, this is a very useful thing to consider. And finally, the very last thing I would like to demonstrate, it's a bit philosophical, and it's a bit about the origins of the open source software and the circumstances behind how this was kind of born back in the day. Well, at least one of the reasons of why it kind of born, and the mindset of people of the time of back in the day was really interesting, and it's really similar to what I currently feel. So I just want to read a single paragraph for you guys. So here is the website. I already have it here. So here is the website from, I believe, from Tom Pittman himself. I might be wrong, but it seems like yeah. So let me just read this. So so you could have enjoyed this with me, guys, as well. So in 1976 at the Homebrew Computer Club, there was a lot of whining about Bill Gates charging $150 for his basic interpreter. And what I mean here, so for instance, I'm not sure about regards the price to the King 1 version of that basic. I don't know how much did that cost, but I know that this basic was used in Commodore PAD or CBM, and it's also been known as the CBM basic. So there were two versions, like CBM 1, CBM 2, and then there were some enhancements as well. So Commodore PAD, Commodore VIC-20, Commodore 64, all those Commodores were using the slightly adopted version of this basic, which mostly was just a matter of renaming the messages that it prints to the screen. So literally was the Microsoft's version of the basic that was running on Commodore computers. The same thing was happening to Apple as well. I believe this was in Apple II, because yeah, where else could it be, right? So for Apple I, Steve Wozniak has created his own Apple I Basic, or also known as the Integer Basic, which was quite similar to the Tiny Basic by Tom Pittman, but a bit more enhanced, and it was about 4K it took about 4Ks of ROM. It was entirely in the ROM, And by the way, that was included, that integer basic was included into the Kimono project by Oscar Vermeulen that I've been inspired by, and I've learned all I know about how Kimono works is literally from researching the source code by Oscar. So Oscar, thank you so much for doing that. But the problem was that when I was trying to, when I've configured the build to include the Apple One Basic in the Kimono sketch for Arduino to be uploaded into Arduino, and I've been uploading this to Arduino Nano, which is similar to Uno, and Oscar originally used Arduino Mini, if I'm not mistaken. But internally, and in regards for like the amount of available memory, like 1K of RAM, 1K of EEPROM, so they are quite similar. But for some reason, I didn't manage to make that Apple One Basic working. So it only could evaluate the string on the fly, so it could like print string, print the expression. But if I try to input in, some program lines here, like we've seen here, and then try to run that, it just started printing some gibberish to the screen, and I had no idea completely like why the heck was that actually going on. So I didn't have the working basic on the Kimono. So that's one of the major reasons why I decided to write, not to write, sorry. That's one of the major reasons why I decided to like build my own, to make my own setup that would actually make it possible to run this, to run whatever, like even some basic on the Arduino, basically, right? So that's the case. All right, so I forgot why I was talking about this, but anyway, so let's go on with the reading. So the idea that that basic, there was the basic written by not written by Bill Gates. It was written by Tom Whalen, if I'm not mistaken, if I spelled the guy's name properly. And Bill Gates was just entered as the Easter egg later on to the program itself. But anyway, the idea that it costed $150 for that, I believe, cassette tape. I believe that they were just selling these cassette tapes back in the day. Might be wrong though. But it's basic interpreter. And Dennis Allison responded by printing a build your own tiny basic article. So, and actually this is another thing that I would love to inspect on my own. I did yet had a look at that article. Not even sure if that is available actually. But anyway, it would be incredibly interesting to try to create your own basic. That would be really fantastic. So I asked if anybody would buy it if it costs only $5, and this is trolling. I believe this is trolling. It's like $150 versus $500. So like dampen Bill Gates with no chances. And there seemed to be some affirmation. So I wrote my own interpreter. Other jumped on the same article, and I wasn't the first done, but I wanted to be paid for my efforts. As far as I know, nobody at Homebrew Computer Club bought it, but I sent a free buy to magazine, and here is another trick. So you just read carefully. So others jumped on the same article. So I believe that Tom Pittman wasn't the only guy who done that, basically. And yeah, he wasn't the first. Done. But I wanted to be paid for my efforts. Well, that's clear. As far as I know, nobody at Homebrew Computer Club bought it. So this means that no one within the dedicated community was actually interested in buying that, because I believe they were kind of interested in doing this on their own. So hence they were not interested. But then he sent us the free version. This is, for me personally, is the born of the open source software. I mean, really, to the Byte magazine, and they printed a 1-inch announcement. So it's a very, very tiny one. So you can hardly see that in the entire magazine, I believe. The next month, my mailbox was full with orders, everyone with $5. So you just got these mails with $5 in them. So this is fantastic. I don't know. For me personally, this is the forever must-have way of how one should be selling software. So literally, just give it away for free, and if it's really good enough, then you will just get donated, and that's how this works nowadays with open source software. So I believe that Tom Pittman was one of the pioneers actually exploring this path, and I think that this is an extremely like important effort that he did in order to like to put into the open source software development in the world in general. I didn't get rich off that, but it did pay a lot of my expenses at grad school. So yeah, that's really nice. So this is all I wanted to read you guys. So yeah, for me personally, this is incredibly inspiring. So and at the end of this video, I just want to ask you, well, for those of you who is kind of familiar with this $150 basic, so for K1 this is KB9 basic, also those who had experience with Commodore basic on, I believe, on whatever Commodore machine. So how for you guys, I'm really wondering which basic would you consider as a user. So would you consider the Microsoft basic adopted for whatever target computer you've been using this on, or this tiny basic by oh my god, I just forgot the guy's name. Pittman, I think Tom or Tim, Tom Pittman. Or so would you consider the Microsoft basic for $150 or Tom Pittman's basic for $5? Please let me know in the commentaries. I'm extremely interested to know what do you guys think about this, and if you elaborate in the commentaries, this would be really exciting. So I'm really wondering, what do you think about this? This is it from my side. Thanks for watching. Until the next time, and take care.